Welcome back. Just a real quick video. This is going to be pertaining to cylinder head flow. Now, you can tune into any of the professionals, guys that have been doing this for 60 plus years, to those that are trying to sell you a product because of the flow number of cylinder heads and the direction they might give you, to valve angles. There's all kinds of different variables that you can be throwing into this. Now, I just happened to see a video from 2 hours ago from Chad Spires. I'm keeping along with some of the other cylinder head porting YouTubers like Eric Weingartner to David Vizard. Now, remember that if you are a machinist, okay, typically your tooling devices are going to create a symmetrical opening. So if you're doing a valve seat grinding or cutting, the entire valve area is going to be symmetrical. It's going to be the same measurement all the way around. But the distance, especially within the combustion chamber or within a half an inch into the port itself, things change. They are no longer symmetrical. And the advantage to hand porting is that you can alter the port or the bowl area of the combustion chamber, or excuse me, of the port, to be most beneficial to your flow numbers. A lot of it's going to be dictated by the pinch that's created by the combustion chamber on the combustion chamber side, and the port approach is also going to alter what happens behind the valve within the bowl area. So if you have followed along with my instruction, a lot of it comes down to the bowl area, and there's multiple things that play into where the power occurs, where the greatest flow and the greatest velocity occurs within the lift range or the RPM of the engine combination. So coming out and getting for peak numbers, like most cylinder head porters will tell you, is always going to be beneficial to the overall power that your engine combination can make. That's not the only variable that plays into this. So remembering whether it's a side profile or the combustion chamber side of things, the actual bowl area needs to be ovaled in some form or fashion. There are areas within the port that will flow more air at higher velocities. Normally, individuals really concentrate on the short turn radius. Remember, within a cylinder head configuration, the short turn radius is normally fixed by the water jackets that flow through the casting itself. So there's limited space for you to be able to open things up or to contour the short turn radius. Likewise, the roof is normally limited to how much material is actually there before you break through into the valve train area or the rocker area of the cylinder head. The sides also have limitations, whether it's between the ports, maybe some cooling passages that go around the spark plug itself, or adjoining ports if they're a Siamese head. So there's limiting factors into every single design. Finding the specific one that creates the most power for your combination is a very lengthy discussion. It's something that can't just be, again, a machinist, when they're making something symmetrical, if they're grinding into the port, the bowl area is not going to be convex or concave consistently all the way around the port. Even guys that are hand porting, if they're making the bowl area the exact same convex or concave shape to them, it's not achieving the maximum power that can actually be produced by the flow of the cylinder head. So, depending on what platform you're working with, the valve angle alters what the bolt area can actually be configured in and how it's going to flow. Some of the higher port, more laid back valve angles, such as the LS cylinder head, that 15 and a half degree valve angle and the raised intake port configuration is not going to be the same performance gain if you're working with a 23 degree first generation small block Chevy cylinder head. So the information that you're getting as far as what's the best way to do things is going to be specific to each individual manufacturer and each design. It's that simple. So while you're collecting information to best modify your engine. There's so many different variables that come into it. Okay, and it's not just the valve size or the RPM or the lift of the camshaft. The actual port approach and the pinch points created by the combustion chamber are going to alter what shape should be mirrored within the bowl area. Okay, so if you tune in to David Vizard, almost every one of his printed articles, his books, or even within his YouTube instruction, he utilizes that symmetrical intake and exhaust port, to where all the way around 360 degrees, all the way around the bowl area should be like a trumpet horn, symmetrical, where it's the same all the way around. Okay, that is not going to work in every situation. It's not going to work when your combustion chamber, say the difference between a wedge big block Chrysler combustion chamber compared to, say, some of your earlier Chevy camel humps with the smaller combustion chamber. It's not going to work with the Ford combination. It's definitely not going to work with a Hemi type cylinder head. So be careful of the information you're getting. It's got to be specific to your platform. It's going to be different between Ford, Chevy, and so on and so forth. Now, all of them are going to be air pumps. Okay, it doesn't matter what manufacturer, what engine you're working with. A 4-stroke engine is an air pump. But the actual design and engineering put into the cylinder head is going to be different between every one of them. They're going to flow different at different rates. They're going to have different velocities. The air current is going to transfer through the design much different from one manufacturer to the other. It has to be very specific. So the formulas that every one of the gurus in the performance industry uses, it's got to be specific to the combination. It can't be a common practice across the industry. It doesn't work like that. Even though they're all air pumps, all of them, they function in different manners. So when we get to these dyno mules or even comparisons between, say, a Ford or Chevy, you have to realize the design was manufactured in a way to benefit a certain RPM or lift from the cam itself with the intended RPM range. In previous videos I've mentioned, don't shy away from some of the manufactured engineering stats. Majority of your manufactured cylinder heads out there, if they're original parts duplicates, I would say a big block Chevy, big block Chrysler, small block Ford, so on and so forth, the engineers were trying to gain the most power in the intended RPM range. You can modify them, obviously, to gain more power, but remember the original design and what the manufacturers were intending to get. That's only going to increase where the power is made within the RPM range. That simple. As far as flow characteristics, importing techniques, they are not the same across the board. So I'm going to give you an extreme example here, referring to some of the more shrouded combustion chambers from the Chevy family. Okay, so if you're the camel hump, smaller 64 or even 58cc combustion chambers, non-Vortec, okay, so the first generation, you'll notice that the combustion chamber, the area the spark plug is located at is very close to the valve. The transition from the open part of the combustion chamber to the valve is not the same around the entire combustion chamber. Okay, so that circles the spark plug. Your transition area from your valve seat into the combustion chamber is very shrouded, even at higher lifts. Even at 600 lift, a small chamber, combustion chamber of the early first generation Chevy will not allow as much air to pass through, say, compared to the mid 1980s fast burn or Vortec design. They are removing material to open it up. More of that kidney shape. That will allow the actual design of the small block Chevy Siamese port configuration to flow more air. It is deshrouding it even from inside the combustion chamber. Now, one of the biggest mistakes that I've learned over 30 years is that when individuals are thinking about performance, especially cylinder head or intake flow, they're always looking at it from the entrance point. How air is actually moving in through the carburetor, through the individual port runners, into the cylinder head, and into the combustion chamber. The flow path of air that you could visually see from the outside in. What individuals forget is that an engine works off of negative pressure. So whether it's vacuum, which is measurable negative vacuum created within a cylinder, to even when the exhaust valve is closed and the pressure in the combustion chamber is less than the ambient air pressure. Okay, so that depending on what altitude you're at, approximately that 14 tons of atmospheric pressure that's being forced into a zero negative pressure area within the combustion chamber after the ignition cycle, so on and so forth. As the piston travels down, obviously that area opens up and the vacuum increases. But intake valves typically start to open up when there's almost zero pressure within the combustion chamber. So the initiation of flow into the port is actually coming from a very low pressure zone. And as the piston is traveling, as the valve opens, that vacuum increases. The negative pressure increases at a greater amount than it can actually pick up from the ambient air pressure, because as the ambient air pressure has to transfer through the intake system, it takes time to be able to flow into the combustion chamber. The old adage, the best cylinder head for any engine is no cylinder head. If you can imagine a piston going up and down in a cylinder without a cylinder head in it, as the piston travels down, it is filling the open area as fast as you can actually spin it. There is no restriction. The valve, the cylinder head, the intake, and carburetor all cause restriction. So the less restriction that you can fix or modify is going to turn into more power. Reverse engineering, thinking about the negative pressures or the lack of pressure inside the combustion chamber, has the effect on airflow from the intake or transferring into the exhaust. So once again, after the combustion chamber or the combustion process, it's working off a greater pressure than the ambient air pressure. So it's a reverse of what the intake is. So the practices of valve seat angles or bowl area configuration is going to be different between intake and exhaust. And it's also going to be different between the actual engineering configuration of the power plant. It is not going to be a fixed formula that you can copy from any publication or take instruction from anybody that's going to be specific to your combination. So again, one of the best investments you can have into building an engine, especially if you're doing your own and you want to modify some things or anything like that, talk to somebody with experience and be very specific of what you're working with. You cannot necessarily take and pick up an article out of Hot Rod Magazine, no matter what year it is, or any publication, even some from David Vizard, that is going to give you the best performance for your application. It takes a trained individual, somebody with a lot of experience, not necessarily selling the components, but understanding how the airflow or vacuum works. And a machine shop will intently try to come out to the point where they can create the modification the most symmetrical way using the machinery. At that point, additional modifications by hand comes down to the talent of the individual and understanding of the original design. Okay, so Again, none of these formulas, the cross-sectional area, anything like that, none of them are formulas that can be shared amongst every situation. It's very specific. If you're working with 23 degree small block Chevy heads, you have to look at those modifications. If you're working with Ford, you have to use those modifications. The formulas are only a generalized direction to take. So again, David Vizard, with over 60 years of experience, his publications have shown that that trumpet symmetrical design within a port achieves the greatest amount of flow during the practices and modifications of street do-it-yourself modifications from the 1980s and 1990s. Realize that we've learned since that point, even to the point where modern day performance geeks, let's call it that, all of us are kind of geeks that way, this idea does not necessarily transfer across every platform. Okay, because the short turn radius within a small block Chevy actually works the best with a convex short turn radius. While the same application within a 23 degree small block Chevy head, or even a Chrysler, flows the best with a concave lead into the valve seat extension. So a machine shop is not going to necessarily be able to modify the bowl area of the cylinder head leaning towards or favoring one side to be convex while the other one remains concave. That can only be done by hand. And within the perimeter, the radius of the bowl area is going to be different from the different clock positions of the valve. So if we're looking at from the combustion chamber side, looking at the valve, 12, 3, 6, 9, the bowl shape is not going to be symmetrical to the back of the valve. It's going to favor more of that oval or egg shape. Okay, that's construed a little bit more extreme just to understand. The area with the greatest opening, typically towards the spark plug itself, is going to benefit the most from a concave bowl area. Where the sides, basically at the 7 and 1 o'clock position, are going to benefit most from actually having a convex bowl wall area. It's not the same 360 degrees all the way around the valve. So again, some of the information, the fixed formulas out there, they're only a guideline that you can shoot for. But it's not the same between every manufacturer. Different valve angles, different floor approaches, different wall approaches is all going to be altered. Now, here's an example for all of you to be able to compare this up, even within the same engine family. Even with the modern small block Chevy LS engine plants, the multiple cylinder head combinations they had between the LS1 cathedral port to the large cross-sectional area LS3 to the small raised port of the LS7, all of the valve angles remain the same. The combustion chambers are also very similar, but each one of those cylinder head designs will flow differently within the lift range of the action of the camshaft or valve itself. The LS1 is designed to have the greatest flow over a larger margin of RPM. So typically the LS1, whether they're equipped in a GTO or a full-size truck, the RPM range of that cathedral port design is to create more velocity throughout the entire port for a specific operating range, something that is going to be driven on a daily driver. The LS3 is going to be designed more towards the individual that's operating in the 3,500 to 6,000 RPM range, typically in your smaller cars, such as a GTO, Camaro, or Corvette. Now the LS7, again, almost identical valve angles, and the combustion chambers are very similar between the three. Is going to actually have the best flow characteristics in the 5,000 to 7,000 RPM range, particularly those used for road race or Corvette type applications. So again, even out of the exact same combustion chamber design or valve angle, the port approach is going to dictate differently between each of them. So if you have a LS guru out there, a cylinder head porter, saying, oh, this is what we do with the bowl area on an LS1, it's not going to be the same modifications that they would do for an LS7, because again, it is altering where in the RPM range and where the flow and velocity is occurring at that RPM. Forget lift. Okay, so there is a parameter, real quick, I didn't create a video on this last week. There was another video talking about valve lift. Okay, every person out there that's in the performance industry right now, they're going to say the maximum lift that you can possibly get within your combination is going to transfer the most amount of airflow, because the valve itself becomes a restriction. No, that is untrue, because there is a point in every combination, every design out there, Chevy, Chrysler, Ford, Chevy, you name it, to the point where the combustion chamber design will actually restrict of when the airflow will start to cut off or drop off. So let's say a 23-degree small block Chevy head, okay, you can get cams that lift up to 660, but you'll lose a lot of airflow, because at certain lift numbers, the amount of reversion before the valve closes that can go backwards within the port configuration is increased with more valve lift. There have been multiple tests out there, especially from the engineers at Direct Connection, Chrysler Direct Connection. They have proven the Chrysler design. So if you're working with a Chrysler small block LA cylinder head and even some of the Magnums, there's a point where valve lift, you're actually going to lose flow because of the air that's going to reverse from the valve. They have tested it multiple different times that within those designs, anything over a 550 lift is actually counting against your airflow. Up to approximately 520 and 525, the percentage of airflow going into the cylinder is greater than the amount that's being pushed back up or reverting into the port. Anything over that, you're actually losing the amount of air that goes into the cylinder. Some of it's actually going backwards. Each design, no matter if it's Chrysler, Chevy, Ford, big block, small block, that valve lift of where it's going to create more power to the ratio that it loses within flow is going to be different. And it all comes down to the specific valve angle, combustion chamber design, and intake port approach. That's where spending time with one engine family. So if you are a hot rodder or you're trying to learn, focus in on one manufacturer design for as long as you possibly can. Learn the ins and outs of that design and read as many articles, use as much common sense as you possibly can before the modifications. But realize if you switch to a different manufacturer, you have to start all over. And it's individuals that have 20, 30, or even 60 years of experience will have an advantage over somebody that might specifically focus on just one design. Okay, so for instance, let's take the guys down in Texas at what are they called now? Can't even think of them now here. Not Einstein Automotive, but they really specialize in LS power plants. The information they might share to you is going to be specific to the LS. Man, sorry, I'm thinking it. Now it's bugging me. Frankenstein, not Einstein, Frankenstein out of Texas. They know a lot about the LS cylinder heads. Okay, so if you're working with an LS and you're turning to them from, for any kind of direction or getting parts from, they're going to know that fairly well. But if you're a Ford manufacturer getting into building LS, so on and so forth, it's not going to equate and transfer over to your specific situation. Flow benches are a tool. Okay, flow benches would tell you the one direction movement of the air from the intake port or through the exhaust. It will not tell you the reversion fraction of the air moving backwards. Reversion has just as much of an impact on power production as intake flow. And where it occurs within the RPM range is also going to dictate the power output for the entire RPM range of the engine. So you have to understand how the flow transfers over the valves, the concave or convex design of the bowl, how it affects the reversion, the ram effect, and where it flows when the valve is reduced in the fraction of flow. So once again, most of your valve angles are there to move the valve away and out of the air movement. There's a certain point where you want to actually have the valve there to block reversion going backwards. So even the design of the head of the valve can dictate when that occurs in the RPM range. It's an extension of everything around it. So again, not picking on anybody, just realize that it is specific to your application. If you're using formulas from any of the performance geeks out here, realize that it might not work the best for your specific circumstance. Reach out to somebody that is a professional with that platform. That's it. Have a good one.